Hi and welcome back to a new video. Today again a new hardware launch. We are going to talk about the 13900K, so the new Intel CPU, which is still going to be compatible for the latest socket 1700 and is now also featuring the new C790 chipset. And without a lot of talking, we will straight head into the first benchmark. We are starting with Cinebench R20. And as you can see, the 13900K is straight on top of the chart. And as you can also see, we tested it against most of the relevant high-end CPUs. By Intel, we have the 12900K and also the KS. And from AMD, we are going to use the Ryzen 7950X and also the older 5950X. And because it's also going to be quite relevant for gaming, we will also compare it to the Ryzen 7 5800X 3D. The focus for today's video is going to be the performance compared to the power consumption. For all of the charts and benchmarks which we're going to show, we will always have the performance and at the same time the power consumption. Just an example here with Cinebench R20, where you can see the 13900K being on top, but you have to pay a price for that. Already, if you compare it to the previous 12900KS, we can see a strong increase in multi-threading performance by 43%. But at the same time, and the 12900KS already had a high power consumption, we are increasing the power consumption by another 13%. If you now compare this to the 7950X, you can definitely feel the increase in power consumption. Even though the 13900K is about 4% faster than the 7950X, you will pay the price of 45% more power consumption. If we now translate this to performance per watt, on the first look, the 13900K doesn't really perform very well. And it will even fall behind a 12900K. Interestingly though, the chart is led by the 5950X, which is a bit older. And it's even beating the 7950X, which is much more recent. Whenever I get new CPUs, usually the first thing I do is I just go straight to Windows. I'm going to check power consumption, I'm going to check temperatures, clocks, and of course performance. If you do that with the 13900K, you will think, hot damn, this is going to consume over 300 watt, so it's also going to run rather hot. And then the performance is not much faster than, let's say, a 7950X. So what's going on? But at the same time, most of the people are just going to game with a 13900K, and that's why we're also going to put the focus on this. But before we jump into further gaming tests, I quickly want to go over the systems I've been using for testing, like the memory and also the mainboard configurations. This would simply be too much information to edit into every single benchmark slide, so we're just going to go over this very quickly. For the older Ryzen 5000 CPUs, I used a Strix B550 board with 3600C14 memory modules. Generally, I tried to use the fastest memory I have laying around, simply to make sure that all the CPUs can perform as well as possible. For the pretty new Ryzen 7950X, I used the B650E Aorus Master together with 6000C30 modules. The 12900K, KS and also the new 13900K were tested on the new C790 Aorus Master, which I got from Gigabyte. But I also want to add that it shouldn't really make a difference, and I could have also tested the 12900K and also the KS on older C690 or even B660 boards. The performance would be pretty much the same. I just made it a bit more simple for me, and that's why I added all of them on the same board. I tested the 13900K with 6200C30 modules. Originally, I wanted to test them with this 6800C34 kit, and there are even higher rated memory kits available, like above 7000 megatransfers, but it just didn't make it in time. But in theory, the 13900K could reach even higher performance than what we're going to show in today's video, simply because there are going to be faster memory modules available, but also much more expensive memory modules. But now going back to Cinebench R20 and also the 7950X launch by AMD. Back then, they were already marketing an eco mode, which is basically putting the 7950X to a constant power limit of 90 watt. And I thought it should be quite interesting to have the same kind of power limit, pretty much an eco mode, also for the 13900K, just to do a direct comparison at the same power consumption. Interestingly, with this eco configuration, both 7950X and also 13900K perform almost the same. It's only about 4% difference. But what I find even more impressive is the difference between the predecessor, the 12900KS, and the 13900K. because they have pretty much the identical multi-threading performance, but now the 13900K uses only a third of the power consumption. Now looking at performance per watt chart directly. And 7950X and 13900K have about the same score with about 120 points per watt. Now changing in the pretty recent 3DMark CPU profile benchmark. It's again a very heavy multi-threading benchmark. 13900K and 7950X are performing exactly identical. But now if we add in the power consumption, you can see that the 13900K needs about 30% more power than AMD's 16-core CPU. But now putting the artificial echo mode back in place with a power limit of 90 watt, they will behave the same again. You can see a huge jump in multi-threading performance going from 12900K to the new 13900K. But in this condition, the 13900K consumes about 60 watt less. Now heading over to the gaming benchmarks, and even though timing-wise this was quite annoying, simply because RTX 4090 launch was only last week, and we had almost no time to test this again with the 13900K, even though we received the 13900K like weeks ago. But yeah, we still wanted to do it with the most recent cards. We tested gaming performance in 1080p and also WQHD depending on the game. And I also want to add that we did not use in-game benchmarks because sometimes this can lead to confusion. For example, if we use Assassin's Creed or like Far Cry, they have built-in in-game benchmarks, but we are using like real in-game material, real in-game scenes, and that's why the numbers might not be directly comparable, just for you as information. In Far Cry 6, the 13900K shows strength, like enormous strength. It's leading the chart and it doesn't even matter if you're running the artificial echo mode with 90 watt power limit. The 7950X is about 22% slower and the 5800X 3D even beats the 7950X. Compared to the very heavy multi-threading benchmarks such as Cinebench or 3DMark, which we checked out earlier, the 13900K can show quite efficient usage in gaming with about 115 watt power draw. By the way, that's also roughly the same power consumption as the 7950X. And talking about the 5800X 3D, it's definitely also worth paying attention to the power draw of this CPU, even though it's just in the middle of the field. But now switching to FPS per watt, you can see the 13900K with a power limit of 90 watt will achieve about 1.82 frames per watt. But that's still behind the 5800X 3D. And at the same time, the Ryzen 9 7950X performs quite bad, 1.24 FPS per watt. I also want to add that it can be quite difficult to have the 5800X 3D in those charts, especially if we do the direct FPS per watt comparison. Simply because this is a heavily gaming optimized CPU that has less cores, and that means, for example, for the 7950X that has a lot more cores, or the 13900K that has more cores, those CPUs will always have higher power draw even if the other cores are not doing anything. So for the FPS per watt and also the efficiency comparison, the 5800X 3D should always be superior. But you should not forget about the fact that in like multi-threading rendering applications or multi-threading benchmarks, the 5800X 3D usually is not really quick. And overall, the 13900K in gaming is usually also faster. This type of efficiency behavior is what we can see again in PUBG. This time we are running a WQHD resolution with esports settings. That means that we're running FPS optimized settings. The 13900K is again on top of the chart, and it's about 35% faster than the 12900K or KS, and about 11% faster than the 7950X. All three high-end CPUs consume about the same amount of power with about 100 watt. Similar to Far Cry 6, again, the 13900K loses almost no performance by running the artificial power limit, pretty much the echo mode, of 90 watt. Even though, and that's what we already talked about, the 5800X 3D is almost the slowest CPU in the test, at the same time it also consumes only 60 watt. And if we now switch back to the FPS per watt chart, that's the strength you can see of the 5800X 3D. But at the same time, you should not forget that the 13900K is only slightly behind, but it's also 40% faster than the 5800X 3D. So at that point, I'm not quite sure if I would really take efficiency over the additional 40% of power. Switching over to Remnant from the Ashes in WQHD, and is pretty much the same result. The 13900K is on top of the chart, and if we now compare the 13900K with the artificial power limit of 90 watt, and also the 7950X in echo mode, which is again also 90 watt, we can see the Intel CPU being about 14% faster while having the same power draw. In Assassin's Creed Valhalla, I have to admit that I was surprised that even running 1080p with extreme settings, it is still limited by the 4090. At least I have no other explanation why all of the CPUs are pretty much scoring identical. It didn't matter if I was using the 12900K, 3900K or even the 7950X. I think subjectively speaking, they should all behave the same. You will not be able to tell a difference. Only for whatever reason the 5950X seemed to have performance issues. You might have noticed that we did not talk about minimum FPS in any of these gaming charts. Usually we add them and we also noted them down. We did comparisons for that, but there was nothing unusual, nothing we could see that one CPU behaves a bit different than the other one. And that's why I left out the information simply to make the charts a little bit easier to digest. Because honestly, there's so much information in these charts, like so many different CPUs and power consumption, that from my opinion, it was just too much information for the charts. You can let me know about that, but I didn't see any kind of unusual behavior. And because I'm pretty sure that all my other YouTube colleagues are going to add these numbers, I thought this would be okay to you, but you can give me feedback on that. Battlefield 2042 will be our last gaming benchmark. And again, the 3900K will be on top and it's very, very fast. But at the same time, I was also surprised that at least for gaming, the power consumption was rather high with about 125 watt. At least if you compare it to the other games which we tested, which were typically around 100 watt. But at the same time, the 7950X had roughly the same power consumption with 15% less performance. I then noticed that there was only a very, very little performance difference between the stock configuration of the 3900K and applying the artificial echo mode, aka 90 watt power limit. We are talking about 4 to 5% less performance, but 30% less power draw. Seeing the results with the artificial power limit of the 3900K, that it had only very little influence of the performance, I was questioning myself if it was possible to further optimize the 3900K, like underclocking, undervolting. Because what you have to keep in mind is that both 3900K and also let's say the 7950X, they are CPUs that are targeted for gaming, but at the same time, like render applications, like professional workloads, and they have a huge amount of cores. And while in gaming you're only maybe using 6 to 8 cores, 75% of the rest of the cores they're not doing anything, but they're still going to consume power, which in gaming will make these CPUs much less efficient. And that's why I thought, let's see what the 3900K has left if we do some manual optimization. In result, I spent multiple hours trying to optimize the 3900K further. Stock, the 8P cores were clocking at 5.5 GHz, at least if the temperatures were allowing it, and if the temperatures were allowing it, for a single core, it was boosting to 5.8 GHz on that single core. The E-cores were running constantly at 4.3 and the cache at 4.5 GHz. With the focus on gaming, the first obvious thing to do would be optimizing the E-cores, because we have plenty of them, and for gaming you don't really need many of them. In my case, I lowered the clock to 2.2 GHz. That is still sufficient to have some kind of performance for some application in the background, such as Discord or like Spotify, and it will reduce the power draw slightly. But because the power consumption mainly depends on the utilization, this optimization only helped about 10 watt improvement. We saw a bigger improvement by downclocking the cache from 4.5 to 3.8 GHz. This helped to improve by about 18 watt. Pretty much as expected, the highest difference can be seen by lowering the P-core frequency. I went down from 5.5 to 5.1 GHz on all of the 8 P-cores, and these were now running at below 1.1 volt, and previously it was about 1.35 volt. This further decreased the 3900K's power consumption by another 35 watt, which results in a total power consumption in gaming, at least here in Battlefield 2042, with slightly above 60 watt. The result is that we cut the power consumption of the 3900K in half, so it's 50% lower. And we're only losing 9% in performance. This is turning the 3900K into a very efficient CPU, and it can even beat the 5800X 3D. With 3.11 FPS per watt, this is going to be on top of the chart. And it's twice as efficient as a 7950X, at least in Battlefield 2042. Similar to what we did with the RTX 4090 review, I wanted to find the sweet spot for efficiency for the 3900K. That's why we're going back to Cinebench R20, and I tested in steps going from 20 watt power limit all the way up to 340 watt power limit in steps of 20 watt. You can clearly see that in the area of 40 to 100 watt, the points of Cinebench R20 are increasing, and especially compared to the power consumption. I also found it quite interesting that in the area of 160 watt and above, it seems to be quite linear. And you should also be aware that in the area from above 280 watt power consumption, my AIO, which was a 280 AIO, was not capable of keeping the CPU cold anymore. And to translate the top of the chart, this means that the last 3 or 4 points of the curve, they were limited by thermal throttling. Otherwise, this would still have been pretty much a linear curve. And that also means that if you are capable of cooling the 13900K further, maybe with custom water cooling, you can probably overclock it a little bit and still get a decent amount of extra performance, which is usually not possible with recent CPUs or GPUs. They will have a very flat curve at the end, but that seems to be not the case for the 13900K. So this still seems to have some performance left in it, if you're able to cool it. And hopping back into the performance per watt chart and paying more attention to the area of 60 to 80 watt, which seems to be a very efficient area of the 13900K with about 130 to 140 points per watt, I decided to go back into the BIOS of the board and set a power target of 70 watt for the 13900K. Reran Cinebench R20, and as you can see, if you want, you can push the 13900K to become the most efficient CPU in the chart. Overall, probably safe to say that the 13900K will be the fastest gaming CPU available, once again. Typically, during gaming loads, we saw a power consumption between 70 to 120 watt, which also means that if you're only going to use the 13900K for gaming, then any decent cooler is going to be fine. Could be a decent air cooler or like a 240 AIO, this will be just fine. But when you're switching to high multi-threading loads, could be Cinebench, could be 3D Mark, could be any render application, it's likely that the 13900K can or will consume above 300 watt and can also instantly lead to thermal throttling, which is not bad just on a physical level, but can be annoying. It can also be annoying because you're going to consume so much more power for only a little bit less performance. It might make sense, depending on your application, to also apply your custom power limit. Maybe go to like 160, 180 watt power draw, and during high multi-threading load, you might see a decrease of maybe 8 to 10% in performance, but 50% less power draw. That might be something to look into depending on your exact application. The thing is though, even if it's the fastest CPU available for gaming, if you purely use it for gaming, you will only use a fraction of the CPU, because most of the features that cause the CPU to have, for example, very high multi-threading performance, like all the E-cores, you will probably not make use of any of these features. This means it might make sense to look into other CPUs like the 13600KF or like the 13700K, because you're going to spend less money, probably going to have exactly the same performance for gaming, and you can still manually optimize this as well. One big benefit Intel currently definitely has is the platform entrance price, because theoretically speaking, you could even use the 13900K on a cheaper B660 board with DDR4. For example, I was checking this, great naming by the way, Gigabyte. It's the Gigabyte B660M DS3H AX DDR4. It's not even 140 euro, it's not going to have the best VRM, but just for gaming, this should be fine. And you have some basic features like Wi-Fi, like 2.5G network, USB-C, and then you add maybe 32 GB of DDR4, which is about 100 euro, and you have a good entrance price into the platform. Whereas for AMD, if you go for, even if it's just B650E or like B650, for the same price you only get a board, and not even a good board. That is something you will have to consider if you're at the point deciding in which platform to step into, like AMD or Intel. AMD definitely still has the advantage that if you're running a high multi-threading load, like render application, the 7950X is just going to be much more efficient. It's about the same performance as the 13900K, but less power draw if you just run plain multi-threading load. But for gaming, the 7950X is going to be worse. And in some cases, even the 5800X 3D is still faster. So much about the launch review performance-wise for the 13900K. We will definitely do some other videos like modifications on the CPUs, overclocking and everything like that. Thanks for tuning in. See you next time. Bye bye.